Hello students and good morning. So now I'm doing class for class 12 science. The topic is the new topic, that is integration by the method of substitution. So in the last online class we finished indefinite integration, and in that case we did some problems. So today we will start the new chapter, that is integration by the method of substitution, right? So what is the meaning of substitution? So if you replace a variable by a new variable, that is known as substitution. So today we'll do integration by the method of substitution. Okay. So now let us take an example. Suppose we have integration of f dash of x divided by f of x dx. Okay. Suppose there is integration of f dash of x divided by f of x dx. Suppose your integration in the numerator there is f dash of x divided by f of x dx. So what is the method of integrating it? Okay. So now suppose this is I is equal to integration of f dash of x divided by f of x dx. So now in this case, while doing the method of substitution, you should have the knowledge of differentiation also. So यसमा चाहिँ तिमीलाई differentiation को पनि knowledge हुनु पर्छ, अनि मात्रै यो हामी method of substitution गर्न सक्छौं. जस्तै यहाँ छ f of x and f dash of x is there. Okay? So what is the relation between f of x and f dash of x? You should know the relation between f dash of x and f of x. You know that what is the relation between f of x and f dash of x? We know that the differentiation of f of x is f dash of x. So हामीले यहाँ जुन चाहिँलाई डिफरेन्सिएसन गर्दै छौं, जस्तै f of x लाई हामीले डिफरेन्सिएट गर्छौं, f dash of x पाउँछौं. तो यो f of x लाई हामी z सपोज गर्छौं. Since the differentiation of f of x is f dash of x, so we can assume this f of x as z. जुन चाहिँलाई हामीले डिफरेन्सिएसन गर्दै छौं त्यसलाई नै हामीले z सपोज गर्नुपर्छ, because in this case differentiation of f of x is f dash of x, so we have to assume this f of x as z. That means we are replacing this variable f of x by z, because the differentiation of f of x is f dash of x. So this method of integration is known as integration by the method of substitution. Okay. त कुन चाहिँलाई चाहिँ हामीले डिफरेन्सिएट गर्दै छौं, f of x लाई डिफरेन्सिएट गर्दै छौं. यसको डिफरेन्सिएसन के पाउँदै छौं, f dash of x. So we have to assume z is equal to f of x. Let us assume the new variable as z. Okay. So let z is equal to f of x. Suppose z is equal to f of x. So while doing the method of substitution in this case, we have to differentiate it again. Is that clear? Because we are replacing the variable f of x by z, so we have to replace this dx by dz also. So that means you have to differentiate this z is equal to f of x both the sides with respect to x. So while doing the method of substitution in case of integration, you have to differentiate it again. You can differentiate it with respect to z or with respect to x. Okay, so let us differentiate it with respect to x. So differentiating both the sides, with respect to x. Okay, so what do we get? Therefore dz by dx is equal to, what is the differentiation of f of x? You know that it is f dash of x. So now in this case we can do the cross multiplication. We can use cross multiplication here. You can cross multiply because we have to get the value for f dash of x dx. This dx should be also replaced by dz. If f of x is replaced by z, you have to replace this dx by dz, so that we can differentiate both the sides with respect to x. So what is dz by dx here? F dash of x. Now cross multiply. What do we get? Or dz is equal to f dash of x dx. So it is dz is equal to f dash of x dx. Okay. So what is the value for f dash of x dx in this case? This is dz. Now we can use, therefore I is equal to integration of, what is f dash of x dx? It is dz divided by, what is f of x? It is z. Now you know this integration. We have done it in the first chapter, that is in the chapter indefinite integration. Now you should know the formula for integration of this is 1 by z dz. That means, what is integration of 1 by z dz? Differentiation of which function is 1 by z? That is log z, and z should be kept within modular sign because only logarithm of positive number is defined. So therefore I is equal to, so now it is log within mod z, what is the base? E, then it is plus c. Now you can put the value for z, or I is equal to log, now you have to put the value for z. What is the value for z? It is f of x. This is your f of x, mod sign close, and what is the base? E, then it is plus c. So this is the answer. So this is the method of substitution. This is the integration by the method of substitution. So what is the integration of f dash of x dx divided by f of x? It is log f of x base e plus c. You can check it also. I told you that integration is the reverse process of differentiation, isn't it? So now if you differentiate this function, you should get this question. That is f dash of x divided by f of x. Now let's differentiate it. Log of f of x. What is this differentiation? It is just like your log x. What is the differentiation of log x? 1 by x. So here it is 1 upon f of x, isn't it? What is the differentiation? 1 upon f of x into, again you have to differentiate the term which is assumed as x. In this case, this f of x is assumed as x. So what is this differentiation? It is f dash of x. And what is the differentiation of c? It is 0. That means we are getting the quotient, isn't it? That is f dash of x divided by f of x. We are getting this one. So this is the correct answer. So we can use it as a formula also. We can use it as a formula also. That is, what is integration of f dash of x divided by f of x dx? That is your log of f of x base e plus c. So I think I've understood it. Okay. So this is the first example of integration by the method of substitution. So suppose this is number 1. So let's do number 2. So now integration of, okay, now within second bracket there is f of x, second bracket closed, whole to the power n, where n is any integer, right? Then into f dash of x dx, f dash of x dx, okay? So now let us do this integration by the method of substitution. So therefore, where n is any rational number also, where n is any rational number, you know the meaning of rational number, isn't it? A rational number is that number which can be written in the form p by q, where q not equal to 0 and p and q are integers which are prime to each other. That means they should not have any common factor in between p and q. That type of number is known as rational number. So here n is any rational number. So let us do this integration. Okay. So I is equal to integration of within second bracket f of x, second bracket close, whole to the power n f dash of x dx. So now how will you do it? Now in this case also we have to use the method of substitution. Okay. So method of substitution means you have to replace a variable by a new variable. Now in this case also you should know the relation between f of x and f dash of x. What is the relation between f of x and f dash of x? That is, differentiation of f of x is f dash of x. So we can assume z is equal to only f of x, not f of x whole to the power n. We can assume z is equal to f of x only, but not z is equal to f of x whole to the power n. हामी assume गर्न सक्दैनौं because f of x whole to the power n को differentiation f dash of x मात्र हुँदैन. You know that, isn't it? So यस्तो पाराले डिफरेन्सिएट गर्नुपर्छ त्यो फंक्सनलाई जसमा कि f dash of x मात्रै आओस्. That is f of x को डिफरेन्सिएसन के हो? f dash of x. यसरी हामी प्रब्लम गर्छौं यो. Is that clear to all of you? So we can assume z is equal to f of x, but we cannot assume f of x whole to the power n as z. Okay? So let us assume let z is equal to f of x. Because यो f of x को differentiation के हो? f dash of x. Now differentiating both the sides with respect to x. Okay, so now let us differentiate it. So I already told you that while doing the method of substitution, if you assume f of x as z, you have to differentiate both the sides with respect to x, because in this case also you have to get the value for dx, or you have to get the value for f dash of x dx. Now dz by dx is equal to, this is your f dash of x. Okay, now we can do cross multiplication. So now let us do the cross multiplication here, or dz is equal to, what is here? It is f dash of x dx. That means we are getting the value for f dash of x dx. So what is I is equal to now? So I is equal to integration of, what is f of x? Z. It is z to the power n into, what is f dash of x dx? F dash of x dx is dz. Is that clear? Now you know this formula from the first chapter. You know this formula, z to the power n. What is the integration of x to the power n? It is x to the power n plus 1 divided by n plus 1. Similarly, it is z to the power n plus 1 divided by n plus 1 plus c. Is that clear? Now you have to put the value for z. Don't leave the answer here. You have to put the value for z also. Then only you will get the correct answer. Okay? So let's put the value for z, or I is equal to, what is the value for z in this case? It is f of x second bracket closed whole to the power n plus 1 divided by n plus 1 plus c. So this is the answer. So in this case n should not be equal to minus 1. Is that clear? यसमा चाहिँ n is equal to minus 1 हुनु हुँदैन. n is equal to minus 1 भने के हुन्छ? 0 0 0. This is f of x whole to the power 0 divided by 0. 0 is undefined, isn't it? In this case n should not be equal to minus 1. If n is equal to minus 1, then this denominator will be 0. If the denominator is 0, it is always undefined quantity. Is that clear? So I think you have understood it. So you can copy it. So just now we did two formula out here. So that is, number one was integration of f dash of x divided by f of x dx is equal to, what is the formula here? The formula is log, right, within mod f of x base e plus c. Okay, and number two, integration of f of x whole to the power n into f dash of x dx is equal to, what is this formula? This one. Okay, so its formula is f of x whole to the power n plus 1 divided by n plus 1 plus c. Here n not equal to minus 1. So we can use it as a formula also. Or if you don't know the formula, we can derive like this. Okay, so you can copy it. So now in the first chapter, हामीले कतिवटा integration गरेको छैनौं त्यसमा. That is integration of tan x dx, integration of cot x dx, integration of sec x dx, and integration of cosec x dx. These formula were not in the first chapter. Now this formula will be included in this chapter, that is integration by the method of substitution. किनभने यो प्रब्लम that is अलि भर्खर मैले जुन चाहिँ चारटा integration भने, that is integration of sec x, integration of cosec x, integration of tan x र integration of cot x. यो चाहिँ method of substitution ले मात्र हामी गर्न सक्छौं. त्यही कारणले गर्दा यो फर्स्ट च्याप्टरमा थिएन. There were no formula like integration of tan x, integration of cot x, integration of sec x and integration of cosec x. These formula are derived in this chapter, integration by the method of substitution. Now we will do the formula for integration of cosec x, integration of sec x, integration of tan x and integration of cot x, right? So you can copy it. Now we'll do that formula. So now we will derive some formula with the help of integration by the method of substitution. So I already told you that we haven't done the formula for integration of tan x, integration of cot x, integration of sec x, integration of cosec x in the first chapter. So this formula may be derived with the help of integration by the method of substitution. त्यही कारणले गर्दा यो integration जुन चाहिँ मैले अहिले भर्खर भने, that is integration of tan x, integration of cot x, integration of sec x and integration of cosec x, यो चाहिँ second chapter बाट मात्र सुरु हुन्छ. So let us derive the formula for integration of tan x first. Okay? So now let us derive integration of tan x. So integration of tan x dx. त हामीले यो फर्स्ट च्याप्टरमा गरेनौ integration of tan x. त यो integration of tan x चाहिँ यो च्याप्टरमा मात्र इन्क्लुड छ. ठीक छ? So let us derive the formula for integration of tan x. So how will you do it? We can write tan x as sin x by cos x. So let us use I is equal to integration of tan x means it is sin x by cos x dx. Okay? So now what is the relation between sin x and cos x? Differentiation of sin x is cos x and also cos x differentiation is minus sin x. That means we are getting the numerator. If you differentiate sin x, if you differentiate sin x, we are getting cos x. That is also correct. If you differentiate cos x, we are getting minus sin x. That is also correct. But which function will you assume as z? हामी sin x लाई assume गर्छौं कि z कि cos x लाई assume गर्छौं z. त माथि यो cos x माथिपटि भएको भए we could have assumed sin x as z. तर यो sin x चाहिँ माथिपटि छ, cos x चाहिँ तलपटि छ. sin x माथि छ भने तलकोलाई डिफरेन्शिएट गर्नु. You cannot assume z is equal to sin x because differentiation of sin x is cos x, but cos x is in the denominator. So we cannot assume sin x as z. Okay? Actually 1 by cos is sec. You know that. And the differentiation of sin x is cos. So since in this case cos x is in the denominator, we cannot assume sin x as z in this case. I think I've understood it. But we can assume cos x as z because the differentiation is sin x, but sin x is in the numerator, isn't it? So we can assume cos x as z because the differentiation of cos x is sin x and sin x is in the numerator. So I think I've understood it. So let us assume z is equal to cos x. Let z is equal to cos x. Okay? So let us differentiate both the sides with respect to x. Differentiating both the sides with respect to x. Therefore, dz by dx is equal to, what is the differentiation of cos x? You know that it is minus sin x. Now we can do cross multiplication and you have to get the value for sin x dx. Okay? So, or dz is equal to minus, this is your sin x dx. But we have only sin x dx is there, but there is no minus sign. You can take this minus sign to the left hand side. So it is minus dz is equal to, this is sin x dx. That means we are getting the value for sin x dx. So what is the value for sin x dx? It is minus dz. So therefore, this is I is equal to integration of, what is sin x dx? It is minus dz divided by, what is cos x? It is z. Okay. So now this is minus, or I is equal to minus integration of, this is 1 by z dz. We can write it, isn't it? Minus sign is taken outside integral sign. Then integration of dz by z means 1 by z dz. Now you know this formula. Differentiation of which function is 1 by z? That is log z. So what is integration of 1 by z? It is log z. So or I is equal to minus log within mod z. Here the base is e plus c, or I is equal to minus log within mod. What is the value for z? You have to put the value for z, that is cos x mod sin close plus c, and what is the base here? It is e. So this is the answer. This is the formula. This is one of the formulae, right? So what is integration of tan x dx? It is minus log within mod cos x base e plus c. This is one of the formula, right? We can derive other formula here from here. So you know the properties of logarithm. So before log, in front of log there is minus sign. And because of this log, this minus 1, actually this is minus 1, isn't it? In front of log there is minus 1. And because of this log, this minus 1 becomes the power of cos x, right? So using properties of logarithm, what do we get? Log within mod. So this is cos x whole to the power minus 1 plus c, and here the base is e. But you should know that this is not an inverse circular function. Your cos x whole to the power minus 1 inverse circular function hoina. Cos inverse x hoina yo. Cos x whole to the power minus 1 la हामी के लेख्न सक्छौं 1 by cos x. So or I is equal to log, so it is within mod 1 upon cos x mod sin close, the base is e, and this is plus c. Or I is equal to log within mod, what is 1 by cos x? It is sec x mod sin close base e, then it is plus c. The u formula like that. We can write down this formula also. So what is integration of tan x dx? It is log within mod sec x base e plus c. So what will be the formula for integration of tan x? It may be minus log within mod cos x base e plus c, or it may be log within mod sec x base e plus c. So these are the formula. Either you can write down this one, minus log within mod cos x base e plus c, or you may write log within mod sec x base e plus c. Is that clear? So this is the formula for integration of tan x. Now similarly you can easily derive the formula for integration of cot x. So this is your homework, right? That is integration of cot x dx is equal to, this is your homework, you can derive it. So its formula will be log within mod sin x base e plus c. So this is the homework, right? So what is integration of cot x dx? It is log within mod sin x base e plus c. Yahi euta mattai cha यसको formula. So you can do it at home. So this is your homework, okay? Now let us derive the formula for integration of sec x. Now let us derive the formula for integration of sec x. So integration of sec x dx. So therefore I is equal to integration of sec x dx. Okay. So how will you integrate it? You know that sec x is 1 by cos x. So if you write 1 by cos x, can you integrate it? The cos x slight difference the 1 आउँदैन. Actually sec x is 1 by cos x. The cos x slight difference it is not 1, it is minus sin x, but there is 1 in the numerator. So we cannot use 1 by cos x here. Okay? So in this case, there is a different method in this case. The method is there is sec x divided by 1. If it is sec x, you have to multiply and divide it by sec x plus tan x. So why are we multiplying it by sec x plus tan x now? You can understand it. Sec x within bracket sec x plus tan x divided by sec x plus tan x. And if you simplify the numerator, you are getting sec square x plus sec x tan x. So that if you differentiate the numerator, you are getting the, if you differentiate the denominator, you are getting the numerator. Let us do it. Okay, you can understand it. That means you have to multiply and divide it by what here? You have to multiply. The method is you have to multiply both the numerator and the denominator by sec x plus tan x. Okay, the method here is sec x within bracket, you have to multiply and divide it by sec x plus tan x. Then only you can do this integration. Okay, and here you cannot use 1 by cos x. I told you already that we cannot use 1 by cos x here, but in this case you have to multiply and divide it by what? Sec x plus tan x. That is the method. Okay, so now or I is equal to integration of, this is sec square x plus sec x tan x divided by, this is your sec x plus tan x. So now you can understand that why are we multiplying both the numerator and the denominator by sec x plus tan x. Okay, so let us check it here. So this is your denominator, sec x plus tan x. So if you differentiate this denominator, are you getting the numerator? Let us check it. What is the differentiation of sec x? Sec x tan x. What is the differentiation of tan x? This is sec square x. So if you differentiate the denominator, we are getting the numerator in this case. Okay, so we can use that method. If the differentiation of the denominator is the numerator, we can assume this sec x plus tan x as z. Is that clear? So let us assume, let z is equal to, this is your sec x plus tan x. So I already told you that while doing the method of substitution, that is z is equal to sec x plus tan x, we have to differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So therefore dz by dx is equal to, what is the differentiation of sec x? This is your sec x tan x. What is the differentiation of tan x? This is your sec square x. Tan x or differentiation give us sec square x. Now we can do cross multiplication because we have to get the value for sec square x plus sec x tan x dx. Okay, or dz is equal to, this is sec x tan x plus sec square x bracket close, then we can write dx. That means we are getting the value of this numerator which is equal to dz. So let us write I is equal to now, so therefore I is equal to integration of, what is sec square x plus sec x tan x dx? It is dz. Okay, so dz divided by, what is sec x plus tan x? That is your z. Is that clear? So now this is the formula from the first chapter, that is log z. Okay, or I is equal to log within mod z plus c and the base is e, or I is equal to log within mod, what is the value for z? Here the value for z is sec x plus tan x, so we can write here sec x plus tan x mod sign close plus c, then base is e. So this is the answer. So this is the formula for integration of sec x. So what is integration of sec x dx? It is log within mod sec x plus tan x base e plus c. So you have to memorize this formula. Okay, you have to remember this formula. You याद गर्नु तिमीहरुले, ठीक छ? अब यसलाई फेरि हामी formula derive गर्नु सक्छ अर्को. Either you can write down the formula for integration of sec x dx as log of sec x plus tan x base e plus c. Again we can derive the formula from here. Okay, again you can simplify it. That means again you can simplify this expression. Okay, or I is equal to, this is log within mod, what is sec x? 1 by cos x plus, what is tan x? it is sine x by cos x, mod sine close plus c. So let us simplify it. Or I is equal to log within mod. What's the LCM? LCM is cos x. So in the numerator we have 1 plus sine x plus c. Okay. So again you can simplify it further. We can use the formula from submultiple angle. You know submultiple angle in class 11. So or I is equal to, this is log within mod. What is 1 here? It is cos square x by 2 plus sine square x by 2. You can write it. And what's about sine x? It is plus 2 sine x by 2 cos x by 2. This whole divided by, what is the formula for cos x? It is cos square x by 2 minus sine square x by 2. Then we can write here plus c. We are just simplifying the expression. Log within mod sec x plus tan x, and the base is e. So let us simplify it further now. So let us simplify it further. Or I is equal to log within mod. Now you know the formula in the numerator. This is from algebra. A square plus b square plus twice ab. What is the formula? Cos x by 2 plus sine x by 2 whole square divided by, this is a plus b whole square, divided by, this is your a square minus b square, which is a plus b into a minus b. That is cos x by 2 plus sine x by 2 into cos x by 2 minus sine x by 2. Mod sine closed, then plus c. Okay, so you can cancel here. Cos x by 2 plus sine x by 2, any square will be cancelled. Or I is equal to log, here the base is what? The base is e. Here you write base e. So not like that, you don't have to write this base e, or you can write it. So within mod, what do we get? Cos x by 2 plus sine x by 2 divided by cos x by 2 minus sine x by 2, mod sine close plus c. Understood? Now you can convert it into tan. So in both the numerator and the denominator, you can convert it into tan by dividing both the numerator and the denominator by cos x by 2. So if you divide both the numerator and the denominator by cos x by 2, and after simplification, what do we get? 1 plus tan x by 2 divided by 1 minus tan x by 2 mod sine close plus c, and here the base is e. Now we have to use compound angle formula. You know the formula, tan of a plus b, tan a plus tan b divided by 1 minus tan a tan b should be there. So instead of 1 you can write tan pi by 4, and before tan x by 2 here is also 1 minus 1 into tan x by 2. So here instead of 1 we can write tan pi by 4, right? So or I is equal to log within mod, this is your tan pi by 4 plus tan x by 2 divided by 1 minus, this is tan pi by 4 tan x by 2 mod sine closed plus c. Is that understood now? This is your tan a plus tan b divided by 1 minus tan a tan b, and you know that tan pi by 4 is always 1. So we can use the formula in this case. I is equal to, here the base is e, log the base is e. What is the formula here? Tan of a plus b. What is tan of a plus b? Pi by 4 plus x by 2 plus c. So this is the formula for integration of sec x dx. Is that clear? So what are the formula for integration of sec x dx? It may be log within mod sec x plus tan x base e plus c, or it may be log within mod tan pi by 4 plus x by 2 mod sin close plus c, and what is the base here? The base is e. So these are the formula. Either you can write integration of sec x dx is equal to log within mod sec x plus tan x base e plus c, or you may write log within mod tan pi by 4 plus x by 2 base e plus c. So I think you have understood it. So now we will do formula for integration of cosec x. Okay, so let us do integration of cosec x. So I think you have understood the integration of sec x dx. Now let us do integration of, let us derive the formula for integration of cosec x dx. So similarly here also you can use integration of cosec x dx as we have done in integration of sec x dx. So in this case also we cannot write 1 by sin x. You know that cosec x is 1 by sin x. If you write 1 by sin x, there is no method, there is no such method for integrating 1 by sin x dx. Okay. So now in this case also, in case of integration of sec x dx, we have multiplied and divided by sec x plus tan x. But in this case you have to multiply both the numerator and the denominator by cosec x minus cot x. Here the denominator is 1, isn't it? Cosec x divided by 1. So you should multiply and divide it by cosec x minus cot x. Okay. So or I is equal to integration of cosec x dx. So in this case, what is the method? You have to multiply both numerator and denominator by cosec x minus cot x. So it is cosec x, you should multiply it by cosec x minus cot x divided by cosec x minus cot x. Then what do we write here? Dx. Okay. So or I is equal to integration of. Next, you can multiply the numerator cosec x into cosec x, cosec square x minus cosec x into cot x divided by, in the denominator you can write cosec x minus cot x dx. Okay. Now why are we multiplying both the numerator and the denominator by cosec x minus cot x? Let us check it. So now we have simplified the numerator here. So now let us differentiate the denominator. Let us check whether you are getting the numerator or not. Okay. So what is the differentiation of cosec x? You know that it is minus cosec x cot x. And what is the differentiation of cot x? It is minus cosec square x. So minus into minus plus cosec square x. That means we are getting the numerator. That is, differentiation of the denominator is the numerator. So we can assume cosec x minus cot x as z. Is that clear? So let z is equal to what? Let z is equal to, it is cosec x minus cot x. Now we can differentiate. So let us differentiate both the sides. Differentiating. I told you that while doing the method of substitution we have to differentiate it. Okay. So differentiating both the sides. Differentiating both the sides with respect to x. So therefore dz by dx is equal to, what is the differentiation of cosec x? You know that minus cosec x cot x. And what is the differentiation of only cot x minus cosec square x? So minus into minus is plus. This is your cosec square x. So I think you have understood it. So let us cross multiply. Or dz is equal to, what is here? You can cross multiply them. So within bracket let us write positive term first. Cosec square x minus cosec x cot x into dx. So we have cross multiplied. Okay. So now we can put it in I. We can put these values in I. So we can put it in I. So therefore what is I is equal to? Therefore I is equal to integration of, now the numerator is dz, isn't it? That is cosec square x minus cosec x cot x into dx. That is your dz divided by what is cosec x minus cot x? It is z. So it is also integration of dz by z. That means I is equal to log within mod z base e plus c. Now we have to put the value for z. Okay, so you have to write down the answer in terms of x. So log within mod, what is z here? It is cosec x minus cot x mod sign close plus c, and what is the base here? E. So this is the formula for integration of cosec x dx. So we can derive other formula from this expression. Again, you can simplify it further and derive other, and you can derive other formula for integration of cosec x. Or I is equal to log within mod, what is cosec x? 1 by sin x. What is cot x? Cos x by sin x mod sin close plus c, and here the base is e. Or I is equal to log base e. What's the LCM here? It is sin x. So it is 1 minus cos x mod sin close plus c. Or I is equal to log base e. Now you know the formula of 1 minus cos x from submultiple angle. What is 1 minus cos x? It is 2 sin square x by 2. You should know this formula. Divided by what is the formula for sin x? You know this, 2 sin x by 2 cos x by 2 mod sin close plus c. Okay, so you can cancel here, this 2 gets cancels, sin x by 2 any square gets cancels. Or I is equal to log, the base is e, and then within mod, what is sin by cos? It is tan x by 2 mod sin close plus c. So this is the answer. So there are two formulae for integration of cosec x. One is log within mod cosec x minus cot x base e plus c, and the other one is log within mod tan x by 2 base e plus c. So these are the formula that you should remember. So let us write down the summary of this formula. Okay, अब हामी यो formula को summary लेख्छौं, जुन जुन याद गर्नुपर्छ अब म तिमीलाई लेखाउने छु. First of all, you copy it. So now let us write down the summary of those formulae. Just we have done it. Okay, so number one formula was integration of f dash of x divided by f of x dx is equal to, what was the formula? That is differentiation of the denominator is the numerator. That means its formula will be log within mod f of x base e plus c. This is one of the formulae. And then number two, integration of within second bracket f of x second bracket close whole to the power n into f dash of x dx, which is equal to, what is the formula in this case? It is f of x whole to the power n plus 1 divided by n plus 1. Then what do we write? Plus c. Here n not equal to minus 1. Okay. Then next, number 3 is integration of tan x dx. What was the formula? It is, this is minus log within mod cos x plus c, and here the base is e. Or you may write log within mod sec x mod sin close base e plus c. So integration of tan x dx, either you can write minus log within mod cos x base e plus c, or you may write log within mod sec x base e plus c. Number 4, integration of cot x dx. So I gave you this as a homework, isn't it? So your integration of cot x dx जुन चाहिँ प्रुभ गर्नुपर्छ यो चाहिँ तिमीलाई मैले होमवर्क दिइरहेको छु. You can do it at home. Okay, so I give you this as your homework. Okay, so that is integration of cot x dx is equal to, what is the formula? It is log within mod sin x base is e plus c. Okay, then number 5 was integration of sec x dx is equal to, its formula is log within mod sec x plus tan x mod sin close base e plus c, or it may be log within mod tan pi by 4 plus x by 2 mod sin close plus c, and what is the base here? The base is e. I think you have understood it. Okay, next, number 6, what was integration of cosec x dx is equal to, what is the formula? It is log within mod cosec x minus cot x mod sin close plus c and base is e, which is equal to log within mod tan x by 2 mod sin close, the base is e and plus c. Okay, so these are the formula you should remember. Okay, so now we can add here tan mx, cot mx, sec mx, cosec mx, where m is a constant quantity. Okay, so let us write down this formula also. Number 7, if you have integration of tan mx dx is equal to, what will be the formula? What will be the formula of integration of tan mx dx? It will be minus log within mod cos mx divided by m plus c. So इसमें dividing by m से लेख्नु पर्छ. In case of differentiation, it should be multiplied by m. What is the differentiation of tan mx? Sec square mx into m. But while integrating, you should write minus log cos mx whole divided by m. The integration ma चाहिँ dividing by m लेख्नु बिर्सिनु हुँदैन. Is that clear? So what is integration of tan mx dx is equal to minus log within mod cos mx whole divided by m plus c. Or you can write, there is another formula, log sec mx divided by m plus c. So there is other formula, that is there is other formula for integration of tan mx dx, which is equal to log within mod sec mx whole divided by m plus c. And then next one is number 8. So what is integration of cot mx dx? So what is integration of cot mx dx? It is just like your cot x dx log sin mx log sin nx log within mod sin x base e plus c. What is integration of cot x dx is equal to log within mod sin x base e plus c. Similarly here it is log within mod sin mx. In case of differentiation, you should write multiply by m. But since this is the case of integration, it should be divided by m. Then you should write plus c. I think you have understood it. Okay. Now similarly you can write down formula number 9, that is integration of sec mx dx. So what is integration of sec mx dx is equal to, what is the formula? Dividing by m हुनै पर्छ. You should write dividing by m, right? So let us write 1 by m first, then log within mod sec mx plus tan mx mod sin closed plus c. So this is one of the formulae. The other formula will be 1 upon m. If you simplify it, you will get log within mod tan pi by 4 plus x by 2 means mx by 2 plus c. Okay. So here the base is e. You can write here the base is e. You may write the base is e. You may write the base as e, right? So this is the base e. this is the base E, this is the base E, right? And this is the base E. Okay, so what is integration of sec mx dx? It will be 1 upon m log within mod sec mx plus tan mx base E plus C, or it may be 1 by m log within mod tan of pi by 4 plus mx by 2, the base is E plus C. Similarly, what is integration of cosec mx dx? So what is integration of cosec mx dx? It is just like this, cosec x dx. Since it is log base E within mod cosec x minus cot x, it will be 1 by m. You should write 1 by m log within mod cosec mx minus cot mx. The base is E and this is plus C. Or it may be, the other formula may be 1 by m log within mod tan mx by 2. The base is E, so plus C. Is that clear? So what is integration of cosec mx dx is equal to 1 upon m log within mod cosec mx minus cot mx mod sign close base E plus C, or it may be 1 by m log within mod tan mx by 2 mod sign close, the base is E plus C. So I think you have understood it. Okay, so these are the formula that you should remember. So यो formula याद छ भने हामी सजिलै integration गर्न सक्छौं, and you should know the method of substitution. If a variable is replaced by any other new variable, then that is known as substitution method. So now let us do some problems from the book, that is SN book, that is Higher Mathematics for class 12 by SN Day. So you can copy it, you can copy this formula. So this is just the summary of the formula that we have just done. So these are the summary of the formula that we have just done. Okay. So now we'll do this question from exercise 6A, right? Exercise 6A, page number 350, 2 mark section from the book Higher Mathematics for class 12 by SN Day. Again, I am telling you that we are doing problems from exercise 6A, page number 350, 2 mark section from the book Higher Mathematics for class 12 by SN Day. So let us evaluate this integration. That means you have to find out the value of this integration. That is number 1, integral of x square cos of x cube dx. So now therefore I is equal to integration of x square cos of x cube dx. Now in this case you should know the relation between the two variables given in the question. That is, what is the relation between x cube and x square? That is, differentiation of x cube will be 3x square. We are getting the variable x square. We can manage that 3 as a constant. Okay. Since x cube differentiation is 3x square, that means we are getting this x square. So we can assume x cube as z. But we cannot assume cos of x cube as z, because what is the differentiation of cos? It is minus sign. But is there sign there? No. So we cannot assume cos of x cube as z. We can assume x cube as z, only x cube as z. Okay, so let us do the solution. Let z is equal to x cube. Okay, so differentiating both the sides, I already told you that while doing the method of substitution you have to differentiate both the sides with respect to x, so that we can get the value for dx also. Differentiating both the sides with respect to x. Therefore, dz by dx is equal to 3x square, or dz is equal to 3x square dx. But here we have x square dx only. So we can take this 3 to the left hand side. So it goes to the denominator. Dz by 3 is equal to, this is your x squared dx. I think I've understood it. That means we are getting the value for x squared dx, right? So therefore I is equal to, this is integration of cos z, isn't it? Instead of x cube you can write z. So it is cos z into, what is the value for x squared dx? It is dz upon 3. So it is dz divided by 3. Or I is equal to, which is the constant out here that you can take outside integral sign? 1/3. Okay. So 1/3 integration of, this is cos z dz. Or I is equal to 1/3 into, what is integration of cos z dz? You have done it in the first chapter. You already know the integration of cos z dz. Or you may ask yourself the question, that is, differentiation of which function is cos z? Differentiation of which function is cos z? हामीले आफैलाई क्वेशन गर्न सक्छौं, कुन चाहिँ फंक्शनको डिफरेन्सिएसन चाहिँ cos z हो? Or what is integration of cos z dz means differentiation of which function is cos z? That is your sin z. So integration of cos z is what? It is sin z. Then you have to write c as a constant of integration. So I is equal to 1/3. This is sine, within bracket, what is the value for z? It is x cube. The value for z from here is x cube, isn't it? Put the value for z, then plus c. So this is the answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 2. This is also the integration by the method of substitution. So let us evaluate integral sine 2 minus 3x whole to the power 7 dx. So let us write I is equal to integration of 2 minus 3x whole to the power 7 dx. So now how will you integrate it? We have to use the method of substitution here. Okay. So this 2 minus 3x should be assumed as z, because this differentiation is only 3, minus 3. 2 minus 3x ko differentiation ke huncha? Minus 3. That means you have to assume 2 minus 3x as z. So let z is equal to 2 minus 3x. Okay. So if you differentiate it, we are getting only minus 3. That means you can get the value for dx in terms of dz. So let us assume z is equal to 2x minus 3x. So I already told you that while doing the method of substitution, you have to differentiate both the sides with respect to x. So differentiating both the sides with respect to x. Therefore, dz by dx is equal to, it is only minus 3. Now from here you have to get the value for dx in terms of dz. Let us cross multiply it. Or dz is equal to minus 3 dx. Or what is the value for dx? It is minus dz upon 3. So I think I've understood it. Okay. So let us put these values in I. So what does I become now? So I is equal to integration of, what is 2 minus 3x? It is z to the power 7, right? So it is z to the power 7 into, what is the value for dx? Minus dz by 3. Minus dz by 3. Okay. So or I is equal to minus 1/3 constant taken outside, z to the power 7 dz. I think you have understood it. Now you can easily integrate it, isn't it? It is just like your integration of x to the power n. It is just like your integration of x to the power 7 or integration of x to the power n. Okay. So you know the integration of z to the power 7, isn't it? Or I is equal to minus 1/3. What is integration of z to the power 7? Z to the power 8 divided by 8. That is x to the power n plus 1 divided by n plus 1. But in this case, it is z to the power 7 plus 1 divided by 7 plus 1. That is 8. So it is plus c. Or I is equal to, this is minus 1 by 8 3s are 24. Put the value for z. What is the value for z? Actually, it is 2 minus 3x. So it is 2 minus 3x whole to the power 8 plus c. So this is the answer. So I think you have understood it. You can do it easily, isn't it? But in this case, in this particular problem, we can use the direct method also. So without using method of substitution, you can do this problem, this particular problem. Okay? There are some problems in which we can do both the methods. That is method of substitution as well as direct method. Okay? So let us write down those numbers in which we can use both these methods, that is method of substitution and the direct method. Okay? That is question number 3. We can use both the methods. Question number 3. Question number 4 2. Question number 4 2. Question number 5 6. Question number 5 6. Question number 8 9 and 10. 8 9 and 10. So now, so regarding these numbers, that is 3, 4, number 2, 5, 6, 8, 9 and 10, we can use both the methods, that is method of substitution as well as direct method. But not for all the other numbers. Aru number ma chai hami both method use garna sakdaina, only method of substitution can be used. But in these problems, we can use both the methods, that is method of substitution as well as direct method. So in this number 2 also, we can use the direct method. So let us do direct method also. You should know the direct method also. Okay? So here, what is I? So I, this is the direct method, right? This is the direct method. So direct method is used only for those numbers, that is number 3, 4, number 2, 5, 6, 8, 9 and 10. Also you can use method of substitution like this for these numbers. Okay? Now direct method is I is equal to integration of, that is 2 minus 3x whole to the power 7 dx. Now if the expression within whole to the power 7 is algebraic expression, if within whole to the power 7, if the expression is algebraic expression, we can assume it as x for the time being. For the time being, we can use this 2 minus 3x as x, right? It is just like your x to the power 7. 2 minus 3x la hami x suppose garu saksau. We can assume 2 minus 3x as x because this is algebraic function. So it is x to the power 7, right? So what is integration of x to the power 7? X to the power 8 divided by 8. We can write here. But here what is x? 2 minus 3x. So it is 2 minus 3x whole to the power 8 divided by 8. Okay? But in this case, which function was taken as x? It is 2 minus 3x. हामीले 2 minus 3x लाई नै x suppose गरेको. That is 2 minus 3x is assumed as x. That is also to be differentiated. So what is the differentiation of 2 minus 3x? हामीले जुन चाहिँलाई x मानिलिएको छौं त्यसलाई फेरि डिफरेन्शिएट गर्नुपर्छ. The function which is assumed as x is also to be differentiated. So what is the differentiation of 2 minus 3x? It is minus 3. You know that, isn't it? 2 ko 0 ba minus 3x ko minus 3. But in case of differentiation, you have to multiply by minus 3. But this is the case of integration. You have to divide it by minus 3. Is that clear? So you have to divide it by minus 3, then plus c. Is that clear? So, or what is I now? So I is equal to minus 1 by 24. You know that. 8 3s are 24. So it is minus. So minus is taken in the front. So minus 1 by 24. Then you can write 2 minus 3x whole to the power 8 plus c. So this is your direct method. So is that clear? Are they equal? Yes, this is minus 1 by 24, 2 minus 3x whole to the power 8 plus c. So for this number 2, we can use both the methods, that is method of substitution as well as direct method. Now we will do this problem by using both the methods. Okay, so you can copy it. Now we'll do number 3. So now we'll do the next question, that is question number 3. In question number 3 also we can use both the methods, method of substitution as well as direct method. So let us do method of substitution first. Okay, so it is integration of dx divided by a plus bx. So I is equal to integration of dx divided by a plus bx. Okay, so now let us use method of substitution first. Now which function is taken as z? We can assume a plus bx as z, because we can get the value for dx. Okay, so let z is equal to a plus bx. So differentiating both the sides with respect to x. Therefore dz by dx is equal to, for a it is 0, for bx it is b. So we can do cross multiplication. Dz is equal to b dx. Okay, or what is the value for dx is equal to 1 by b dz. That is dx is equal to 1 upon b into dz. So I think I have understood it. So let us use this value here in I is equal to integration of, what is dx here? 1 by b dz divided by, what is a plus bx? It is z. Understood? So which is constant here that you can take outside? So therefore I is equal to, which is the constant here that you can take outside? 1 by b. So it is 1 by b integration of dz upon z. And you know this integration. What is integration of 1 by z dz? That is your log z. Or I is equal to 1 by b log within mod z base e plus c. Right? Now put the value of z. Or I is equal to 1 by b log within mod. What is the value of z? It is a plus bx. It is a plus bx mod sign close plus c. And what is the base here? E. So this is the final answer. And for this question you can use the direct method also. So let us use direct method now. So now this is the direct method. So let us do direct method here also. Right? Direct method pani garau यसमा. Let us take I is equal to integration of dx divided by a plus bx. Now in this case we can use the direct method here also, and since a plus bx is an algebraic expression, we can assume it as z. But the power of x should be always 1. x को power चाहिँ 1 हुनै पर्छ. तर x को power चाहिँ 2, 3 भन्छ. There is different method. That is in the next chapter. त्यो अर्को chapter मा हामी गर्छौं. But since here the power of x is 1, we can assume a plus bx as x. What is integration of 1 by x dx? You know that this a plus bx can be assumed as x. So what is integration of 1 by x dx? It is log x. You know that, isn't it? Or you can write here log within mod, what is x here? A plus bx, and the base is e here. But in this case, which function was taken as x? A plus bx. That function is also to be differentiated. Yo a plus bx लाई हामी x suppose गर्यौं त्यसलाई फेरि differentiate गर्नु. So what is the differentiation of a plus bx? That is your b. What is the differentiation of a plus bx? That is your b. So this whole divided by b. So in case of differentiation you have to multiply it by b. But in case of integration you have to divide it by b. Okay? Then you can write plus c. So directly we are getting the answer here, right? So I is equal to 1 upon b log within mod a plus bx, base is e plus c. We are getting the same answer here also, isn't it? So I think I've understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is evaluate. Question number 4, number 2, integral sine sec square within bracket 7 minus 4x dx. So in this problem also we can use both the methods, that is method of substitution and the direct method. So let us do method of substitution first. Let us write I is equal to integration of sec square within bracket 7 minus 4x bracket close dx. So in this case, we can use method of substitution. Now, which function is assumed as z? That is 7 minus 4x should be assumed as z. So let z is equal to 7 minus 4x. Okay? Now, I am differentiating both the sides. Differentiating both the sides with respect to x. Therefore, dz by dx is equal to, what is this differentiation? It is only minus 4. For 7 it is 0 and for minus 4x it is minus 4. So now let us cross multiply it and get the value for dx. Here it is dx. Get the value for dx in terms of dz. So dz is equal to minus 4 dx. Or what is the value for dx now? It is minus 1/4 dz. So I think I've understood it. So let us put it in I. So now I becomes I is equal to integration of sec square. First of all, you write sec square. What is 7 minus 4x? It is z. Into what is dx? The value for dx is minus 1/4 dz. Understood? So now what will you do in the next step? Minus 1/4 is constant. It is taken outside integral sign. So therefore I is equal to minus 1/4. It is taken outside. Then integration of sec square z dz. Then it is sec square z dz. Okay. So or I is equal to minus 1/4. Now what is integration of sec square z? हामी आफैलाई क्वेशन गर्न सक्छौं कुन चाहिँ फंक्शन को डिफरेंशिएशन चाहिँ sec square z. Differentiation of which function is sec square z? Tan z. That is, it will be tan z plus c, or I is equal to minus 1/4. Let us put the value for z. You have to put the value for z. What is the value for z in this case? It is 7 minus 4x. It is 7 minus 4x, then plus c. So this is the final answer. So I think you have understood it. Okay. So let us use direct method now. So let us use direct method. Now we can use direct method in this case. Let us write I is equal to integration of sec square within bracket 7 minus 4x dx. Okay. Since in this case also within bracket 7 minus 4x is there, and since the power of x is 1, we can assume 7 minus 4x as x. But if it happened to be x square, then we have to use other formula. Okay, that is given in the next chapter. Since it is given the power of x here is 1, we can assume 7 minus 4x as x. So it is sec square x. Now, differentiation of which function is sec square x? It is tan x, right? So, or I is equal to tan. What is x here? What is x in this case? It is 7 minus 4x. Okay? Now, which function is assumed as x? हामीले कुन चाहिँ फंक्शनलाई x मानि लिएको 7 minus 4x. That function is also to be differentiated. So what is the differentiation of 7 minus 4x? You know that it is minus 4. But in case of differentiation, you have to multiply it by minus 4. But this is the case of integration, so you have to divide it by the differentiation of 7 minus 4x, that is minus 4. Then you should write plus c. Or I is equal, what is the final answer? Minus 1/4 tan of within bracket, minus 1/4 tan of within bracket 7 minus 4x. Then what do you write? Plus c. So this is the final answer. So I think you have understood it. You can copy it. Now we'll do the next question. So now this question number 5, 8 and 9 are your homework. That is, question number 5 is integration of sine of 3 minus 4x dx. Here you can use both the methods, method of substitution as well as direct method. And question number 8 is also your homework. That is integration of e to the power 2 minus 3x dx. Here also you can use both the methods. You do both the methods, that is method of substitution as well as direct method. And in question number 9 also, this is your homework, that is integration of 10 to the power 2x minus 5 dx. So here also you can use both the methods, that is method of substitution and the direct method. So let us do this question number 6. So here also we are using both the methods. So let us use first the method of substitution. Okay, you have to evaluate integration of cos square 2x plus 3 dx. So let us assume I is equal to integration of cos square within bracket 2x plus 3 dx, right? So let us use method of substitution first. Now here we can assume 2x plus 3 as z. So let z is equal to 2x plus 3. We can differentiate. So while doing method of substitution, you have to differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So it is dz by dx is equal to, what is it? 2. Or what is dz is equal to? It is 2 dx. You know that, isn't it? So it is cross multiplied. Now let us get the value for dx. 2 is taken to the left hand side. So dz by 2 is equal to dx. dz by 2 is equal to what? It is dx. Is that clear? So what is I now? Therefore I is equal to integration of cos square. What is 2x plus 3? It is z. Into what is dx? What is dx? dz by 2. So dz by 2, or I is equal to, this is your half integration of cos square z dz. It is integration of cos square z dz. So I think you have understood it. Okay, so half is taken outside integral sign, integration of cos square z dz. So I already told you that whenever you have sine square or cos square, you should convert into multiple angles, that is you should multiply and divide it by 2, so that we can use the formula of 2 cos square z is equal to 1 plus cos 2z, or 2 sin square z is equal to 1 minus cos 2z. Now here there is cos square z, you should multiply and divide by 2. So therefore I is equal to, this is 1/4 integration of, we are multiplying and dividing by 2, so it becomes, half becomes 1/4 integration of, it is 2 cos square z dz. Is that clear? So now what is the formula for 2 cos square z? Or I is equal to 1/4 integration of, this is, you know this formula, 1 plus cos 2z dz. Now you can separate the term. I is equal to 1/4 integration of dz plus 1/4 integration of cos 2z dz, right? So or I is equal, this is 1/4, what is integral sign dz, z, plus 1/4 into, what is the integration of cos 2z? That is differentiation of which function is cos 2z? That is sine 2z upon 2 plus c. Is that clear? Now we can put the value for z, or I is equal to 1/4. What is the value for z in this case? What is z? It is 2x plus 3. So this is your 2x plus 3 plus 1 by 4 to the 8. Then it is sine 2 into, what is z now? What is z? It is 2x plus 3. Your z is 2x plus 3, then plus c. Now we can multiply here. I is equal to, what is 1/4 into 2x? This is x by 2 plus 3 by 4 plus 1 by 8. it is 1 by 8. Then what do we write? It is sine, now multiply by 2 here. This is 4x plus 6 plus c. That is 2 into 2x. 4x plus 2 3s are 6. Okay. But since in this case you don't have to write 3 by 4 because 3 by 4 is constant. We have already written c out here. No need of writing this 3 by 4 because 3 by 4 is also a constant term. Only you have to write down in terms of x and c should be there. So it is not necessary to write down 3 by 4. So you can write just c only. So what is the final answer here? I is equal to x by 2 plus 1 by 8 sine of this is 4x plus 6 plus, you don't have to write this 3 by 4 because c is already written out here because 3 by 4 is also constant. So you don't have to write this 3 by 4. You just write only c. So this is the final answer. So I think you have understood it. So let us use direct method here. अब हामी direct method गर्छौं है. Okay. So now let us use the direct method. Now we are using the direct method. We can use direct method in this case. So the direct method is, let us write I is equal to integration of cos square 2x plus 3 dx. So let us use the direct method in this case. Without using method of substitution, we can use direct method here also. Okay. Since there is cos square x form, so first of all you have to multiply and divide by 2 so that we can use the formula from multiple angles. Or I is equal to, this is half integration of 2 cos square, this is 2x plus 3 dx. Is that clear? So instead of x there is 2x plus 3. So this is your 2 cos square x dx, isn't it? What is the formula? 1 plus cos 2x, you know this formula. 2 cos square x is equal to 1 plus cos 2x. Is that clear? So or I is equal to half integration of within second bracket 1 plus cos 2 into what is x here? It is 2x plus 3 second bracket close dx. Is that clear? So now we can multiply them or we can separate the term. Half integral sine 1 into dx plus this half should be multiplied by this cos, right? Integration of cos multiply by 2 multiply 2x plus 3 by 2, what do we get? It is 4x plus 6. Then we can write here dx. Or I is equal to, this is half x plus half into what is integration of cos x form. We can take this 4x plus 6 as x. We can take this 4x plus 6 as x and we can easily integrate them. So what is integration of cos x dx? It is sin x, but here it is sine of 4x plus 6. But this is not the only integration in this case because we have assumed 4x plus 6 as x. So it is cos x, is differentiation is sin x. But here it is x is 4x plus 6. But again you have to differentiate the term which is assumed as x. That is 4x plus 6 should be differentiated again. That is, what is the differentiation of 4x plus 6? It is only 4. So in case of differentiation you have to multiply it by 4. But since this is the case of integration, you have to divide it by 4. Then it is plus c. So or I is equal to, this is your x by 2 plus 1 by 8 sine of, this is your 4x plus 6 bracket close plus c. So this is the final answer. So I think I've understood it. Both are same expression, same answer, isn't it? That is x by 2 plus 1 by 8 sine of 4x plus 6 plus c. Okay. So while doing direct method, you won't get this 3 by 4. Direct method गर्दा चाहिँ यो 3 by 4 भन्ने term चाहिँ यहाँ आउँदै आउँदैन. Is that clear? I think I've understood it. Now let's do question number 10 next. So now we'll do the next question, that is question number 10. We can use both the methods in this case, that is method of substitution as well as direct method. So you have to evaluate this question number 10, that is integration of dx divided by within square root ax plus b. So let us use the method of substitution first. So therefore I is equal to integration of dx divided by root over ax plus b. Now since here within square root there is an expression ax plus b, and here the power of x is 1. This is ax plus b. So we can assume ax plus b as z. So let z is equal to ax plus b. So I already told you that while doing the method of substitution, we have to differentiate both the sides with respect to x. So differentiating both the sides. So differentiating both the sides with respect to x. Therefore, dz by dx is equal to a only. For b it is 0. For ax differentiation is a, and for b it is 0. So, or let us get the value for dx. Dx is equal to what is here? It is dz upon a. Is that clear? So therefore I is equal to integration of what is dx? The value for dx is dz by a. So it is dz by a divided by root over z. Root over ax plus b was assumed as z. Okay? Or I is equal to 1 by a is constant taken outside, integration of this is dz divided by root over z. Is that clear? So how will you integrate dz by root z? Now root over z should be taken to the numerator. You know root over z is z to the power half. So when this root over z goes up in the numerator, it becomes z to the power minus half. So or I is equal to 1 upon a integration of z to the power minus half dz. Okay. So now here root over z is z to the power half, and it is taken to the numerator, becomes z to the power minus half. So what is this integration? Or I is equal to 1 upon a into z to the power minus half plus 1 divided by minus half plus 1 then plus c. Okay. Next, or I is equal to 1 upon a into what is integration of z to the power minus half? It is z to the power half divided by half plus c. Right? Or I is equal, now you can simplify it, half for 2, it goes up in the numerator, it is 2 by a, and z to the power half means root z plus c. Or I is equal to 2 upon a into root over z1. What is z? It is ax plus b. Z is ax plus b then plus c. So this is the answer. So I think you have understood it. So this is the method of substitution. This is the first method. Now you can use again the method of substitution, but since this is under square root, if the expression is under square root, you can assume z square also. You can assume either z like this. So if you assume z square, what is the advantage of using z square? You know that root over z square is z. Is that clear? So let us use this method also in case of method of substitution. So let us write again. This is the second method, right? This is your second method. But this is also the method of substitution. But in this case, we can assume z square is equal to ax plus b. So whenever you have the expression on the square root, and if it is in the denominator, we can assume it as z square. So that root over z square is also, root over z square is always z. Okay. So I is equal to integration of dx divided by root over, this is your ax plus b. Okay. So let us use again the method of substitution, but let us assume in this case ax plus b as z square. So whenever the expression is under square root, and if it is in the denominator, we can assume z square is equal to ax plus b. So let z square is equal to ax plus b. I think you have understood it. Okay. So now in this case we are doing the method of substitution. You have to differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what do we get? What is the differentiation of z square with respect to x? Differentiation of z square is 2z into dz by dx is equal to a only. For ax, differentiation is a, d by dx of x is 1. That is only a plus what is the differentiation of b? B is 0. Is that clear? So next, so now in the next step, let us get the value for dx now, or 2z dz is equal to a dx, right? Or what is the value for dx? It is 2z dz divided by a. I think you have understood it. Okay. So now what is I is equal to? Therefore I is equal to integration of, let us put the value here, dx. What is the value for dx? It is 2z dz divided by a divided by, that is root over z square, isn't it? It is root over z square, right? So which is constant out here that you can take outside? 2 upon a. It is 2 upon a integration of dz divided by, what is root over? Oh, it is z. This is z dz, right? Only 2 upon a is constant, that is taken outside. Integration of this is z dz divided by, what is root over z square? That is z. So here z gets cancels, or I is equal to 2 upon a integration of dz. So what is integration of dz? 2 upon a integration of dz is z, then plus c. But what is the value for z in this case? If z square is equal to ax plus b, what is the value for z? यहाँबाट z को value कति हुन्छ? Z is equal to root over ax plus b, isn't it? So we can put the value of z here, or I is equal to 2 upon a root over ax plus b plus c. So this is the answer. त तिमीले कुनै पनि मेथड युज गर, डिफरेंट मेथड्स, आन्सर चाहिँ सेम आउनु पर्छ. Is that clear? 2 upon a root over ax plus b plus c. त यसमा मेथड अफ सब्स्टिट्युसन हाम्रो दुईटा मेथड युज भयो. One is assuming ax plus b as z, and the other one is assuming z square is equal to ax plus b. Is that clear? So now let us use the direct method now. Now we will use the direct method. So now let us use the direct method in this case. So this is the direct method. Okay. So I is equal to integration of dx divided by root over ax plus b. तर यहाँ square root भित्र x को power say 2, 3 भयो भने चाहिँ we have to use the different methods that is given in the next chapter. But since in this case the power of x is 1 within square root, we can use the direct method here. Okay. So without using method of substitution you can do it. That is integration of dx divided by ax plus b whole to the power half. You know that square root means whole to the power half. Now it is taken to the numerator, so it becomes ax plus b whole to the power minus half, then dx, or I is equal to, now since the power of x is 1 here, we can assume this algebraic expression as x. It is just like your x to the power n. We can assume ax plus b as x. So it is just like your x to the power n. So what is the integration of x to the power n? It is ax plus b whole to the power minus half plus 1 divided by minus half plus 1. Is that clear? But which function is taken as x? Ax plus b is taken as x. That is also to be differentiated. Okay? The function which is assumed as x is also to be differentiated. Okay? So what is the differentiation of ax plus b? It is a. ax को डिफरेन्सिएसन कति भयो a अगाडि आउँछ डिवाइड x of x is 1 that is a and b को लागि के भयो 0 a plus 0 is always a but in case of differentiation you have to multiply it by a but since this is the case of integration you have to divide it by a that is you can write into 1 by a plus c. Is that clear? So or I is equal to now this is ax plus b whole to the power what is minus half plus 1? This is whole to the power half divided by minus half plus 1 is also half into 1 by a plus c. Is that clear? Next, let us simplify it further. I is equal to, now 2 goes up in the numerator, half go 2. Half is in the denominator. Now, your half go 2, 2 goes up in the numerator, so it becomes 2 by a. 2 by a, and you know whole to the power half is square root of ax plus b. Then you can write plus c. So this is the final answer. The answer same आउनु पर्छ है. That is 2 upon a within square root ax plus b plus c. So this is the direct method. So your last time हामीले कतिवटा मेथड गरे तीनटा मेथड. One is using z method and the other one is z square method and this is the direct method. So I think you have understood it. You can copy it. So this much is for today. So आज हामीले जति पनि प्रब्लम्सहरु गर्यौ यो सबै घरमा रिभिजन गर्नु. होमवर्क दिएको पनि गर्नु. रिभिजन गर्नु. This is very very important chapter. यो राम्रोसँग बुझ्यो भने नेक्स्ट च्याप्टर एकदमै सजिलो भएर जान्छ. ठीक छ? त राम्रोसँग यो प्र्याक्टिस गर्नु. इन द नेक्स्ट अनलाइन क्लास विल डु मोर प्रब्लम्स अन दिस मेथड अफ सब्स्टिट्युसन. सो दिस मच इज फर टुडे.